Alright, continuing. This is Dr. Franklin Nolan. We are proceeding and finishing up with Chapter 6. We're moving into Chapter 7, Study of Enterprise Java Bean. This is by Emmett Brave, summer 2005 at the California State University in Chico, California. This master's thesis QA can be found 76. Bravo 49/28/2005. Continuing with Chapter 7. We just finished 6, which was message-driven beans. Refer back to the previous lesson for the references. I'll cite them, but I won't give you a breakdown of those references until the end. I'll show you a recording of the actual references themselves. But moving on into Chapter 7, Airline Reservation Systems. To support the study of the EJB and the J2 double echo architecture as a whole, I developed an application that simulates an airline reservation system. The main aim of this application is to successfully put in use the layered approach that the EJT2's architecture follows, and emphasis lies on excuse me. Emphasis lies on using the EJB's servlets and the Java naming and the directory interface, the JNI, Java face, and Java naming and directory interface. The Java database connectivity, the JDBC, and the other components of the J2 double echo, rather than the application complexity in terms of the business logic. Canola doesn't go down so well. Okay, let me briefly describe the application per se. It facilitates the online reservation of an air ticket. First time the user creates their login profile, wherein they need to give a personal information, including their first name, last name, address, contact, email, social security number, the SSN. They also require to create a unique username and password for their account. Herein, all transactions are carried out using the username. The client username becomes the primary key, and it uniquely identifies each user. And the client can change personal information, such as addressed in the contact information. However, the clients are not allowed to change their username or password or social security number. If the client forgets his password, then he or she will be prompted to enter his username and the password will be emailed to him. Okay, once the client are logged out, they can either go for making a new reservation or canceling the existing reservation. When they go for making a new reservation, they can choose the origin, city of departure, the destination, city of arrival, and the date of travel, along with the number of persons traveling, and if they wish to, return journey also. After this, it will be prompted to verify their details. Also, at this time, they'll be shown the arrival and departure and total fare of the journey. If they approve their selection, they can go forward to pay with their payment option. Here, the client must select the credit card and the expiration date for the card. And this is then recorded into the database and then processed in an email of confirmation with all the flight details. The itinerary, rather, is sent to them. They are prompted to log out or go back to do more reservations. When the reservations are made, a unique passenger name record, the PRN, passenger name recorder, is generated automatically by the system. This PRN is then used for the transaction related to the reservations. If they wish to cancel any of the reservations, they need to provide a unique PRN that identifies each ticket. Then the corresponding entry from the reservation and the payment tables is deleted, and the email is sent to them about this cancellation. This is a brief overview of the functionality provided by this application. Let us discuss the technical aspects of the application. The application has been developed in 4 different layers, and the view of the presentation layer is implemented in a Java server page, the JSP. The JSP provides functionality of embedding the Java code into normal HTML code. This Java code provides the dynamic content of the user's views. All the JSP pages pass the control to various servlets on the server side. These servlets serve the purpose of controller by acting as the second layer of this architecture. They accept the request from the JSP page and decide what action is to be taken, and accordingly invoke the corresponding EJBs. Traditionally, servlets used to have the business logic also, but the introduction of the EJBs, we have separated the business logic from the servlets and have put that into the EJBs. The EJBs process these requests, fetch the data from the database, and pass it to the servlets. The servlets then redirect the response to the appropriate JSP page. The EJBs act as a model in the architecture. In this architecture, they form a third layer in this architecture and aim. The aim of my project is to shift the business logic from the servlet to the EJBs and explore different types of EJBs to deploy them as components. EJBs are regarded as scannable, reusable, reliable components. Servlets make use of the JNDI to locate the EJBs, and the JNDI is naming the lookup service provided by the J2 double echo container. The EJBs have to be registered with the JNDI so that other components can look up and utilize their services. I have incorporated the entity beans to handle the database transactions. These entity beans interact with the database and do all the necessary work. I've chosen the bean management persistence to get more control over the actions carried out by the EJBs, and other popular choice as container managed persistence, in which the EJB container takes care of all the transaction management for the developer, but this particular approach lacks the control over the database, and the EJB developer has to be dependent upon the EJB containers. The EJB container uses JDBC to connect to the database. It is up to the container whether to implement the ready pool of bean instances. Now coming to business logic, I have used the session beans to handle their business logic in the application. The logic such as generate the unique PRN is independent of the client, and EJBs does not have to be tied up to a specific client, so that I have chosen the stateless session beans for this purpose. I have employed the message-driven bean, the MDBs, to demonstrate their use, and even though they are not required by this application, whenever a new reservation is made, that triggers and sends the message to a queue. The MDB is designed to process and manage this asynchronously, and then corresponding message is displayed to the user upon successful completion of the reservation process. Once the reservation is made, along with the payment process, an email comprised of the details is sent to the customer. For this, I have employed Java Mail. Java Mail is another API that provides the entire necessary interface to send and receive emails in J2 double echo framework. The mail application can be configured so that we can read the mails for any type of transaction. If the email bounces due to any reason, we can invalidate that. transaction for this, I have tried to read the subject and body of each email. Depending upon the subject, I look further into the body and get the PRN from it and undo this transaction. Alright, so that's into 7. Chapter 8, Technology Overview. That is the E2 double opt overview. Let me describe this Java 2 Enterprise Edition. This various technologies and APIs over the years, the J2 double echo has become a de facto standard for developing and deploying scannable portable enterprise applications. That's from reference 3. BQ1 Java for the web, and serverless JSP and EBJs. This is not a product by itself, but is a set of specifications that provide guidelines for the infinite software vendors, the ISV, to build the J2 double echo containers, and JSEE standards is promising and time-tested solution, and it has already established itself as a proven technology. A large number of companies are developing enterprise solutions based on this. There are various players in the market that provide the J2 double echo complaint platform for application servers. Notable among them are the IBM Web Spheres, the 5.0 BEA WebLogic 7.0, and the Sun 1 Server 7.0, and that can be found in reference 4, Sun Microsoft System Compatibility, and J2 double echo compatibility of Java verification references. As of today, they all comply with the minimum functionality specified by the J2 EE version, the 1.3. It specifies the component architecture and the services that should be provided by the or any J2 double echo container, but the actual implication of each container varies from vendor to vendor. Each container provides a minimum support, but the developer is unaware of these internals of the container. The J2 double echo takes the advantage of the J2 standard edition, J2 SE, and the main language support. Apart from that, it includes extensive support from Java servlets, Java server page, enterprise Java bean, XML technology. That's from reference 11, which is also the Sun Microsoft and the Java server technology, Java technology, J2 double echo. The J2 standard comprises of all these specifications and various compliance tests to make sure that the applications are portable across multiple platforms, conforming to Java write once, run anywhere. And that's from reference 2. Also, Sun Microsoft Systems Java 2 Platform Enterprise Edition, that's the J2 double echo Java technology. And today, more thrust is being given to developing scannable, portable, reliable, and reusable enterprise components from traditional two-tiered architecture, and systems are moving towards the multiple-tier applications. And at this time, when it adds more flexibility, it adds more complexity too. To minimize the complexity and have a common reliable architecture across multiple platforms, the J2 double echo has defined various J2 double echo platforms. These platforms are often greatly advantageous because they provide more standard platforms for development and reduction time to market, since the infrastructure is well defined. And all 21 patterns are defined for presentation, business, and integration layers. Table 1 lists the J2 double echo pattern for all these different tiers. And this comes from our second reference. It's also Sun Microsoft Java 2 Platform Enterprise Edition, J2 double echo, Java technologies, and that is statement Before we move into the Java server pages, the JSP Java server pages is an answer of the Java technology for active server pages, the ASP, and the ASP, or Common Gateway Interface, the CGI, for mixing dynamic content with the HTML contents in the consolidated efforts for the ISVs and technology grants. These technology giants in the software industry making this architecture highly scalable. Web developers use this technology to develop and maintain the dynamic web page very fast. This technology or specification is in nature of extension of already mature Java servlet technology. The JSP, along with the servlets, offer a good alternative to creating dynamic web pages. They have several advantages like flexibility in usage, ease of maintenance, improved performance, extensibility and separation of view from the logic. The JSP pages run inside the JSP engine, and our table 1 reference pulls out our tier name, presentation layer, business tier, integration tier, and our patterns. Name patterns are intercepting filters, front controller, context object, application controller, view helper, composite view, service help. Service help, dispatch view, business, database, delegated service locator, sessions, facade, application servers, business object, object, composite entity, transfer object assembler. We have the value list handling, data access object, server, activator, domain store, web service broker, and the synopsis of each. Let's go through it one at a time. The presentation layer, intercepted filter, the synopsis of the tier to pattern name. The synopsis facilitates the pre-processing and post-processing of a request. Also within the presentation layer, we have front control. The front controller provides the centralization control for request handling. That's the synopsis. So still within the tier name presentation layer, we have pattern name, contextual object encapsulates the state in which a protocol has an independent way about itself. Presentation layer, application control, centralizes the modularization, modularizes the action and view of the management. Presentation layer, applicator control, centralizes the modular and action and view to management. Presentation layer, view helper, composite view, moves to separate processing logic from view. Presentation layer, service to help. Service to helper invokes the business processing prior to the view processing. Presentation layer, pattern name, dispatch view invokes new processing prior to business processing. Moving into the new tier, business tier, coming into pattern name, business delegate, server, service locator, encapsulates access to a business. Encapsulates access to a business. Centralized business logic for lookup services and components. Business tier to pattern name. We've got session facade exposes course and gain services to remote clients. We've got business tier to pattern name application services. Aggregates behavior to provide a uniform service layer. We've got business object, composite entity, also under the business tier, pattern name, encapsulates the business data and logic, implements persistent business and object using entity being. Business tier to transfer object, we've got carries the data across a tier. Transfer object assembler assembles a transfer object from multiple data sources. Pattern name, value list handler. Last and finally, under the business tier, manages search and iteration of a large set of results. New tier name, integration tier is the data access object. The abstract encapsulates the access to persist store. interrogation tier. Service activator provides asynchronous access to one or more service. Integration tier. Pattern name domain store provides transparent service for business objects. Integration tier pattern name web service broker exposes one or more services using XML and web protocols. Our source here is source data used table creation from D. Arthur J. Kupri and D. Malcolm's Court. J2 double echo patterns, that is from Saddle River, New Jersey, Princeton Hall, PRT, Sun Microsoft Systems Press, used with permission. Okay, and that sits on top of the servlet engine at runtime, and the JSP page gets translated to a servlet and it gets executed from the server side. So moving into the JSP advantages, we got the case of servlets, and business logic and dynamic content are part of the servlet itself. So any major change in the view leads to a recompilation of the servlet. In case of the JSP logic got restricted to the external Java Bean component, they can be used instead of the JSP page using the scriptlets and the special tags. Also, like servlets, the JSP pages are compiled at runtime. So it also follows the Java technology paradigm: write once, run anywhere. Also, the dynamic content can be displayed in a variety of formats. They can be displayed like normal, the HTML pages, or on wireless devices like PDAs, cell phone using the XML. It provides a web layer in an in-tier architecture. It provides higher levels of abstract over serverless APIs, comparison of the JSPs with Microsoft Active Server pages. The JSPs are platform independent like Microsoft Active Server pages. The ASP pages run only on Windows-based servers, if you didn't notice already. JSPs support various component models like Java Beans, EJBs, and custom tags, libraries. ASPs components are based on COM technology. The JSP page supports Java scriptlets, and JavaScript ASP supports the VBS scripts and the JavaScripts. So JSP follows the Java security model. ASP follows the Window NT security model. JSP uses the JDBC to connect to the database, and that's formulated from reference 13. Sun Microsoft system with JBBC technology, Java technology, J2 double echo, from the standard link we've been using before, website link. JSPs use Active Data Object ADO for database connectivity. Also, we have the JSP supports custom tag libraries and the JSTLs. However, the ASP is not extensible. It does not support any custom libraries. Moving into the JSP architecture. JSP architecture is shown in Figure 1. See here that the iJSP file is greater than the percentage at page import equals Java to utility at dot asterisk instead of. Alright, get it? Got it, good. This Figure 1 JSP architecture of servlet basically is saying that the JSP file has the page import that equals the Java utility needed for gathering, hence the percentage signs within the greater or less than brackets. And then the HTML code goes here.